Hi everybody. So today's lesson is for you to solve problems on voltage, current and resistance relationships. So you've got all the three and you've got all these diagrams here. So I just thought I will talk you through a couple of things and so then you can do the rest on your own. So I've just kind of drawn some diagrams and I've color coded. So the first one's got two resistors A and B. The resistances are all in red, the voltages I put in blue, and the current I put in green. Now, the thing that we have to remember is higher the resistance, greater the voltage across that resistor. Okay? And also, higher the resistance, smaller the current. So it's that's all to do with Ohm's law. So if voltage is the same, if current decreases, then resistance increases. Okay? If current remains the same, if voltage increases, resistance will also increase. Okay, so for the first one, we have to figure out what is the voltage across B. And so here, resistance A is 1, resistor B is 3. So this is 3 times more. So the voltage across B will also be 3 times more. This is already 2 volts. So 2 times 3 is 6. So your answer here is 6 volts. So that's how you do that one. The next one here, we've got to figure out two voltages. One is the voltage across B and the other one's the voltage across the source. Okay, so now let's compare the resistances. B's resistance is 4 ohms compared to 1 ohm for A. It's 4 times more. So the voltage across B will be 4 times more than the voltage across A. So 3 times 4 is 12. So the voltage across B will be 12 volts. Now in a series circuit, the voltages add up. So 12 plus 3 is 15. So the voltage across the source will be 15 volts. Okay, this is question number 7. Now in question 7, this is where current comes in. So there's current coming in from the source and it splits into 2 branches. Okay, so there's 2 amps flowing through the middle branch. There are 2 ways of doing this. So one way is the resistance in the bottom branch is twice as great as the resistance in the upper branch. So only half the current will go through here. So if it's 2 amps here, it's only going to be 1 amp in the, wrong color. It's only going to be 1 amp here. That is one way of doing it. There's also another way of doing. In any parallel circuit, the voltage across that is the same. And we know that voltage is current times resistance. Okay, so 2 times 3 is 6. Okay, so what times 6 is 6? 1 times 6 is 6. So current times resistance will always give you the same voltage. So I'm just giving you another way of solving it as well, okay, by using Ohm's law. And then this one here, we've got to figure out a couple of things. So all the values in the bottom branch. So there's 3 amps coming through here, through the main branch. 1 amp goes in the middle branch. So the remaining current goes through the bottom branch. It's 2 amps. So let's do it the voltage way. 1 times 2 is 2. That is 2 volts. So 2 times something is 2. So 2 times 1. So the resistance across this branch will be 1. It also stands to reason. Smaller the resistance, bigger the current. So that's how you do these questions. I hope you'll be able to do the rest of them. The answers are also there on the page behind. Okay, bye for now.